Alright guys, in today's video we're going to be working on finalizing these prototypes. I've been working on this for a couple of weeks, trying to refine the design. This is to install a Minimalist fan bracket on the standard MK8 hot end. And this is one of many prototypes in this process. The challenge that I had originally with this is printing it with minimal supports or supports that were easy enough to remove. And I got the design just right as far as the supports go. So just take your time, pick out the supports. I'm using 5% ink fill here. And just carefully work these things till you get them out. I like printing in PETG. I haven't tried printing this in PLA, so I don't know if that's going to work because it does get kind of close to the hot end at the bottom. So currently it will fit the Micro Swiss hot end as well as the stock MK8. So this is the shorter hot end. So the only one that does not fit directly is the CR10S Pro V2. If you have the Micro Swiss hot end for that printer, it is longer. So it's going to throw all the measurements off. The fan ducts won't align properly. So what I recommend that you do is get the Micro Swiss hot end for a standard CR10 or Ender 3 and install it on your CR10S Pro V2. So here I have the CR10S Pro V2 bracket, and it attaches just fine. But you are going to have to make a few modifications to the printer, but we'll go through that during the video. So here's the little fan that comes with the CR10. Also, it's the same fan that the Ender 3 V2 comes with. So what you do is just, I got holes cut out here. So just push this hole through. And then I have these really small screws that I had left over from another project. I'll have to measure them and find something comparable that you guys can use. I'll link it in the description. Okay, so this is a fan duct that I created using the Ender 3 V2 fan duct as a model. But this is very easy to print. So you would print it sitting like this on the print bed. So standing up like this, and then make sure that you have brim on for the outside. Print it very slow at 25 millimeters per second, and with your parts cooling fan at 100%, you'll be able to print this. I had the hardest time. I wanted to throw this slide up here. This is the way it needs to be oriented in your slicer. Ducts are going to be facing up, brim on outside as well as brim on inside. You're not going to need any supports. Just print slow at 25 millimeters per second, 20% ink fill, and it should be good to go. This just slides in there, and then you just use 2 more fastening screws. Alright, so that's one fan. And I'm going to install the second fan. And I picked these fans up on Amazon. 24-volt fans. They do have to get the wires out from these little fastening tabs, because it has to, because the opening is right behind this space right here. See, it fits real nice in there. Yeah, be patient, because it takes, these screws are small. They're tricky to work with, at least for me they are. If you have a hard time getting your fan in here, you may just need to just file these edges a little bit. That's what I'm going to do. Sometimes these the moles that these fans come out of are a little bit different. So I'm just going to give it a little file here. It shouldn't take very much. So you can see that. That one did perfect right there. Then what you do here is just take this wire, push it into this hole here, and then it should come out. Looks like I got a little obstruction in there. It should come out the top. Anyway, you may have to fiddle around with it a little bit to get the wire up in there, but you can get it to go. Okay, so that's our wire all nice and neat. Now the last part would be to install the heatsink fan. So it's best to use a fan like a Noctua, just because it's quieter, but the stock fan will work as well. And again, just take the wire off its little holder. And this hole should fit another set of wires. Hopefully I made it big enough that it will. Now what I'm using here is some screws that I picked up at Harbor Freight. I'll put a link to those in the description as well, along with their sizes. So if you guys have a few of these screws lying around, you can use them. there you have it, guys. So now we got a super compact dual duct, ultra quiet, because these fans don't produce a lot of noise. Now the one thing I will tell you about using a dual fan is that they make kind of like an oscillating noise. So because you'll have two, the oscillating noise will be more apparent. But anyway, I had this set up when I had the all metal hot end. By the way, this fan shroud will work on the micro Swiss all metal hot end as well as the stock CR10 hot end and Ender 3. So I'll mount this on the printer here shortly, and then I'll show you guys how it works. Guys, here it is all put together and assembled. And anyway, this thing works awesome. Ender 3 V2. Now it's compatible with the MK8 hot end that comes standard on the CR10 and Ender 3. So now you guys have a cooling solution that is super compact. Add an Octua fan to it on the heatsink cooler, and this thing will be ultra quiet. There's space, enough space there on the side for the thermistor and heater cartridge cables, as well as access to the pneumatic coupler on the top, the clip to hold the Bowden tube in. And I like it the way it is, just like this. I do have a shroud that I created for this, but the shroud will only fit the Ender 3 V2 because it fastens in the back using one of the bolt holes. Alright guys, let's install it on the CR10S Pro V2. Start by removing your filament. Take apart any wire fastening devices that you have. Remove your BL Touch. And I'm gonna unplug mine. Remove the BL Touch bracket. And I'll include an updated bracket. The original bracket, if you had the assembly the way I did here in the video, is going to be too low. So I had to reposition the location of the BL Touch. I just moved it up, I want to say about 4 millimeters. That way it didn't interfere with the bed. Take off any wire loom or wire organization covers that you got, any sleeves. And then I'm going to try to get as many wires that I don't need in my way out of my way, like the parts cooling fan cables as well as the heatsink fan. Make sure that you have something on top of your build plate to protect it so it doesn't get all scratched up. Loosen your heater cartridge. And the temperature probe. Take the screws loose that hold the hot end to the bracket. Here it is. And I just want to show you the difference between these two. So the one on the left, the longer one, is the CR10S Pro V2, all metal hot end that you would get from Micro Swiss. But it's not going to work for this fan bracket. So what I'm going to do is I'm going to switch the heat sink portion with a block that I had already pre-tensioned. So it's going to make the whole thing a little bit shorter. That way all the fan ducts line up. So this is essentially the same size as the MK8 setup. So that's the only difference. So if you guys are thinking about doing the all metal hot end and direct drive assembly and you want to use this fan shroud, just make sure that you get the Micro Swiss hot end for the Ender 3 or CR10 and not the one for the CR10S Pro V2 because it's too long. But anyway, everything else fits just right. So install the Bowden tube. Now we're just going to slide the assembly into the fan bracket. Get one of your parts cooling fans and install it. And I have the ducts installed on this, but I did find that it was easier to leave the ducts out off until later on, once you already have the assembly already attached to the gantry. And then stick your little wires in, so you're going to go across the front of the hot end and then in through the hole on the side. Then take your other parts cooling fan, install it on the other side. Again, if you can leave the ducts off until later, that's better. Check to make sure that all your ducts are fastened properly. And you don't have to get crazy tight with any of these screws, just snug them up just a little. And that's all you need. So here I'm just checking the tension on the little fastening tabs. Everything looks good. And then the last thing would be to install the parts cooling fan. Now, you're not going to bolt the parts cooling fan in. I'm sorry, not the parts cooling fan. You're not going to bolt the heatsink fan in. You're just going to run the wire, pull the slack out as much as you can, and then just leave it off to the side because we are going to need access to the inside of this fan bracket to screw the hot end to the assembly. So it's best to run the heater cartridge cable and thermistor wires through the channel of the bracket and then install it on the hot end before slipping the hot end into the assembly. Otherwise, you're not going to have the clearance needed to put these fastening screws in. And just slide the heater assembly into the hot end assembly into the bracket. And again, I'm putting the ducts on here, but you really should leave them off till later because they were in my way as I was trying to get this thing all lined up and seated in its bracket. Now this part is kind of tricky, putting this little section of tube in here, because if you see there's a little ledge where the thing fastens, so you kind of have to pull the bracket out a little to be able to get over that ledge until it fits inside the pocket that's in the back of the adapter. But once you slip it up and over, then it'll lock in place, and you just put the screws in to fasten it all down. So now lastly, you just gotta install the parts cooling fan. I'm sorry, the heatsink fan. Pull the slack out on the cable, and then what I did to make it a little bit easier on myself is I had pre-tapped the place where these screws go in. So I used the original screw, but I did it without the fan being there. I just ran them in, and then now I'm just putting them back on with the fan. Once that's done and all snugged up, just arrange your cables, get them all nice and straight. And if you're using a BL Touch or CR Touch, go ahead and install that wire. And that wire is going to run on the channel that's on the left side. So let me move the camera here. Okay, so you can see that channel on the left side. Just run your wire down through there. And I'm going to plug mine in. But I had to remake the bracket so that it raises the BL Touch up a little. I'll have all of this in the STL file linked in the description. Now this is going to be a paid part, $3.49 for the finalized fan bracket, but it does include the new BL Touch bracket along with the new fan ducts. And you also have access to any future updates. So if I change anything, add a shroud or whatever modifications I make to this file, you guys will have access to it, those of you that purchased it. If you just want to try it out and you're not feeling like committing to purchasing it, I do have the original prototype that's friction fit. You can use that. It will fit on the all-metal hot end for the Ender 3. And if you enjoy it and it works really well for you, please consider supporting my work. So what we're going to do here with the parts cooling fan is these cables need to be joined together. So what I'm going to do is, instead of trying to put two cables into one connector, I'm just going to strip back one of the cables and wrap it around one of the other wires and then just tape it. So that's what I'm doing here now. So you want to take your time here and make sure that you leave yourself enough slack. And the reason that I'm not soldering these connections here is that if the fan assembly ever needs to be worked on, I want to be able to undo this real quick without having to unsolder a bunch of things. So this is just one good way that I found to be able to take this apart quickly to service the fan assembly if I need to. So I picked up this pretty cool tape. It's tape that they use for wiring harnesses of cars. It's got a sticky backing, but it's not electrical tape because it's kind of like a fiber type of material that they use. And I picked up a couple of rolls of that on Alibaba. So what I'm doing here is I'm just pulling a couple of the pins out from this little Molex. I'm going to use them on one side. And this is going to be the side that if I needed to service, I could pull these wires through those openings that I made in the fan bracket. That's the reason I'm using these little pins. And then on the other side, what I'm going to use is the JST style connectors. And you guys saw this tool on one of my previous videos. This thing works great. I highly recommend this. If you're into 3D printing, it's a tool that I've used already a bunch of times since I purchased it. And another thing that I like to do is I like to stagger these connections instead of putting them side by side. In the event that for whatever reason I happen to have forgotten to turn the printer off, I'm not going to short anything. Or if anything loses its insulation or protective covering, these wires won't touch. So these two wire ends, all I'm going to do is solder the little pins that I have, which is the other side of the JST connector. And for this part, I'm just going to solder them on. These are little pins. Just adding a little solder at the end of the pin and attaching it to the end of the wire. So what this is going to do is allow me to push this pin into the JST connector without the Molex. That way it's not a real big bulky thing inside the wire, and if I have to undo this and take the fans out, I can do it pretty easy. So that's it. So it'll slip in there and it'll grab the connector. It won't lock in, but this wire with the tape and being inside of the protective wire sleeve, I don't think they're going to come off. Now I'm just going to repeat the same process with the heatsink fan cables. So here I got the two ends. I'm just going to stagger the connection. I'm going to use the same JST connector with the crimper on that side. And then install the pins on the other end. Alright, so now I'm just going to push my wire sleeve back over the cables, and before I do that, we're just going to turn this thing on and test it real quick. Yep, everything looks like it's working. And by the way, guys, if you guys find a solution for finding a way to hold this wire up so it's not hanging down the way it is, let me know. I've been racking my brain trying to find a way to keep this cable up off the build plate. So if you guys have any suggestions, let me know. I was thinking about a drag chain, but you see how when it goes over to the limit switch, it gets right up against it. I don't know that a drag chain is going to work for me. So here I just did a quick auto home, and now we're gonna need to start fine tuning this. So this was the point that I discovered that the BL Touch bracket was still too low, so I had to remake it and bring it up a little. So what we see here is the original spacer for the Z-axis stepper motors on the back, and if you notice, the bracket is almost touching. So we're going to have to modify this part because I still have to bring the tip down about another millimeter. It doesn't look like it here in the video, but that tip is still about a millimeter off the print bed. So I do need to bring it down, but these brackets are going to interfere. So this is why Creality has the longer print head for the CR10S Pro V2 is because of that bracket. So we're just going to jump on to Onshape here real quick. I created a document, changed the measurement of units to millimeters, and then just using the measurements of the original part, I'm going to recreate it, but then add the modification to it. So this is just going to be real quick. If you guys want to watch this in more detail, just slow the video down in this section. That way you guys can see what I'm doing and follow along. So yeah, I just created my countersinks, 45-degree angle. And then now I need to create the cutout. So the original part had like a convex portion in the middle of the part, and it was about a 20 millimeter round tool could be used to punch out this shape. So the 20 millimeters is exactly the size of the collar that holds the Z-axis rods. So that's the reason, is to clear that collar so you can put this part in. So I'm just pushing it through here. And that's a cool thing about using CAD software. It's just like using tools, but they're digital tools. So instead of using a tool head or drill bit to drill a hole, you're just using a digital shape to punch the hole, and then the 3D printer just prints it. Anyway, I think it's awesome. So here I'm creating the two holes for the smaller screws that hold this bracket to the stepper motor. Both sides are going to be equal, so once I get the measurement off the original part, I just transfer it over to here. So now this is exactly like the original part, and then this is the part that we're going to change. So I'm going to add a line here. Now I put 45 degrees here, but really it's 50. You guys will get the correct angle on the download link, because after I printed mine, I noticed that the angle was not right. I just left it on mine, but for yours, the angle should match the bracket. So since I took that section of material away, I need to countersink this one side screw. And then also the screw is going to have to be a little shorter. Now I had extra screws in my bag of screws for my CR10S Pro V2, just from some of the changes that I've made. Some of the screws I no longer had use for, but I did keep them. So this shortens the original screw by about 5 millimeters. So the screw is going to have to be a little bit shorter than the original one. And then I'm just matching up the same type of look that the original part had. It had a bunch of rounded corners. That's the reason I'm doing this. And that looks pretty good. All right, perfect. Now, next thing I need to do is I need to mirror this because I need to have a left and a right side. You can also mirror it in your slicer. There is a mirror feature there. But I'm just going to mirror it here and then just supply two separate STL files, one left and one right. So this is how you're going to orient them on your slicer, flat side down. And then just print it. This is the completed part. And then this is what it looks like compared to the original. So the only difference is it's got the one side that's countersunk, and then it has that angled side to allow the extra clearance. And installing it is pretty easy. Just take the original one off. And be careful because the two bigger screws that hold this little bracket to the rail, they have a couple of washers behind them. So don't pull the screws out because the washers will fall behind the stepper motor and you'll have a harder time getting them out of there. So what I found is to just tilt this bracket up and it'll the screws will keep the washers from falling out. There you go, just like that. So here you have it. There's the new part. And to hold these washers to the new part, I found that you can use a little bit of stick glue. So I'm just using some stick glue here. And just sticking the little washers to it. And then just like before, put your bolts in from the bottom. And then slide it on top of the stepper motor. And then turn it so that the screws fall down into the rail, and then you can easily reassemble it. Just tighten everything down and then do the same thing for the other side. So now I'm going to bring the gantry down and you can see the extra clearance. And the reason that we need to do this is to set our gap between the print nozzle and the bed. Because since this is a shorter print nozzle, those brackets were interfering with the spacer, and now we don't have that problem. Alright, so now I'm just doing a quick auto home, and I'm going to create a new mesh since we made some changes to the hot end. I'm going to check my gap. So what I'm using here is a 0.1 millimeter feeler gauge, and there was some plastic oozing out of the bottom there, so I had to push that out of the way. But I like doing this, using this 9 square bed test whenever I make changes to the hot end or the bed. That's going to affect my my Z offset. So I'll just write down, you can see me on the right side writing some little squares, and then as this thing starts to print, I'll take notes of what the Z offset is at that particular print, part of the print, and then determine which one is the best one. So I'm not going to go over all those steps here. This video is already long enough, but if you want to watch me do that, I do show that process on my Ender 3 videos, the one where I install a brand new Ender 3 with all the upgrades. So now I'm just printing the little square, and I think I show be printing maybe one of the squares. So this first one was way high, but then as the prints progress, I make adjustments while it's printing until I get the right one. Once you determine what the correct Z offset is based on the changes you've made, just store them in the EEPROM, and then the next time you restart your printer, everything should work perfectly. So these are the changes that you can make while it's printing. And it gives me this ability with the Tiny Machines firmware. But I believe the original one does it as well. So this was one of my good ones. And this is what you want. You don't want the nozzle dragging through the filament, but you want to make sure that the filament is adhering to the build plate. So guys, here it is complete. And then I'll run off a couple of test prints so you guys can check it out. Yeah, I'm super impressed. It's very compact. It looks really cool. And it's been working great. I tested it last night on a V3 Vapor Blast gun, and it did a really good job. So here's a airflow test that we're going to do. Just to give you an idea how good these 4010 blower fans can be with the proper duct. So I've seen a lot of videos online of these hot end fan assemblies using these big huge blower fans and stuff, and they don't get as good a performance as these two small 4010 fans. They're slim, they're small, they're quiet, and I gotta tell you, Creality nailed it with the fan duct design on the Ender 3 V2, because that's essentially that's what this is. This is just a dual version of that fan assembly. Yeah, I'm super impressed with it. Anyway, guys, if you like the videos I'm putting out, give me a thumbs up. If you're new to the channel, consider subscribing. Turn on your notification bells. That way, when I put out new content, you guys will know. And leave me some comments. I love reading the comments. And I do my best to respond as soon as possible. Thanks, guys. God bless.